Okay, so we're going to look at the results of our experiments, look at some of the questions, and look at some facts about the electromagnetic spectrum. So first question, why were the radio waves blocked with the screen? So we found out that when we put the radio inside the screen, the radio waves could not get through. And the reason for this is, if we look at this poster, the radio waves, the wavelengths can be as big as a mountain. And in fact, some radio waves are even bigger than the Earth. So radio waves are very, very large. They are blocked by metal. And the metal screen, the holes of the metal screen are too small to allow the radio waves in. Okay, which material blocked all the invisible light rays in the experiment? This material was the aluminium foil, the metal. But this aluminium foil is not thick enough to block X-rays and gamma rays. When you go for an X-ray, they put a thick lead apron on you. Lead is a metal, so they put a thicker metal apron on you to block the X-rays. And gamma rays will take an even thicker metal or really, really, really thick concrete to block. X-rays and gamma rays are much more stronger in energy. Okay, which object was the hardest to block? We found that the cell phone was the hardest to block. The microwaves of the cell phone were the hardest to block in this experiment, and we'll be talking about that later. Okay, infrared light is just below the visible part. It's just below the red part of the visible part, and the infra means below. So infrared means below red. Ultraviolet is just above the purple part of our visible spectrum, and the ultra means above violet. So that's where those two names come from. The ultraviolet light looks violet because there is some visible purple light mixed in with the invisible ultraviolet light. So we cannot see ultraviolet light. It just looks purple because of the visible light there. Now, the electromagnetic spectrum is arranged according to wavelength or frequency. So the highest wavelength are the radio waves. And then as we move across from microwave, infrared, visible, ultraviolet, X-ray, and gamma ray, the wavelengths get smaller and smaller, and the wavelength of a gamma ray can be smaller than an atom. So it's arranged from wavelength. It's also arranged, as we know, a short wavelength means a high frequency. So gamma rays have the highest frequencies, and radio waves have the lowest frequencies. And as we found out with our Slinky experiment, when we have a very high frequency, we have very high energy. Okay, the only part of the electromagnetic spectrum that we can detect with our eyes is the visible part. But there are many animals and insects that can detect other parts of the spectrum, particularly the ultraviolet. We use the electromagnetic spectrum an awful lot in our everyday lives, and I'll come back to that. And all of these rays are types of light, and they all travel at the same speed, which is the speed of light. They can travel through space, empty space. They don't need a material to travel through, unlike sound waves. And they all are transverse waves. So we're thinking of our Slinky experiment when we move the Slinky from side to side. Also, space scientists, astronomers, when they look at the universe, they look at it, they look at all the different types of light coming from it. So, for example, this is the Whirlpool galaxy, a picture taken of the Whirlpool galaxy with visible light. And these are simulations of what this is the Whirlpool galaxy with the X-rays coming from it, ultraviolet, visible, infrared, and radio waves coming from it. And the scientists get different pieces of information from each type of wave. So, for example, with an infrared, the whiter it is, that means the hotter it is. So the hottest part of the galaxy is in the center, and then we have some other hot spots around there.
Okay, the last thing we looked at this week is what would life be like without the electromagnetic spectrum? And so we looked at the uses of all these different types of waves. Radio waves are used for TV signals, for GPS, for listening to the radio. Wireless internet uses radio waves, and navigation systems. Microwaves are used in cooking, radar, cell phones, and also some TV programs. Infrared waves are used, the heat is used for cooking, infrared cameras, fluorescent lights, TV remote control, and heating. Ultraviolet waves are used to kill bacteria for hospitals, and ultraviolet on our skin makes vitamin D for us. X-rays are used to take X-rays of our bones and dental X-rays of our teeth, and they can use X-rays to find little cracks in different structures. Gamma rays are used to kill cancer cells and also to sterilize food and medical equipment. And also we look at space. So for example, in astronomy, we'll pick up radio waves from space. We'll pick up ultraviolet waves from space, X-rays, and infrared. So we use all these waves in astronomy.